As we moved into the 1950s, using Second World War technology that was used to spot the German U-boats, we got an increasing idea of what was happening on the seafloor. And of course that was the group of evidences that led to the theory of seafloor spreading. You can look at the oceans here on a map like this, which is centred really around the continents, and the oceans wrap around those. But it's possible to have a completely different map projection. So we move over here to the Sulfawas map projection. This one takes a little bit of getting your eye into, but there is Europe, Africa, Antarctica, Australia, and we're up here into Japan, and down to North America and South America. In fact, as you can see from this one, it's the continents that are wrapped around the oceans, as opposed to the oceans wrapped around the continents. So this one really amplifies what the ocean floors are like and what they're doing, and this allows us then to explore that evidence in a new way. But I'm in a pretty special place that allows us to do this in a pretty unique way, so let's have a look. And that's what I call a map projection. So let's go on a journey, seeing what some of this evidence might be. And we're going to start with the British Isles and the Atlantic Ocean here. Over there is New York and North America, there's Greenland. But if we come west from the British Isles to Iceland here, we can see the Mid-Atlantic Ridge. In fact, it starts way up here in the Arctic Ocean, and it comes down through Iceland because we've got the hotspot underneath here. And in the middle of this, we have got our Central Rift Valley, there it is. We've got our transform faults cutting across, and we've got this massive, big ocean ridge that's coming all the way down here in the middle of the Atlantic Ocean. Huge, big ridge. If we look over here, where have we got to? We got to West Africa, and over here is Florida, and there is this massive big ridge coming down here, and it's kind of following the shapes of the continents. It's in between the middle of them. It's exactly the right position, exactly the right shape, as if this is the scar that's been left behind as those continents ripped apart by the process of seafloor spreading. If we come down here, we can still see this ridge coming around here and round here, and the ridge is separating now Antarctica from Africa. Again, the spreading ridge exactly where we would need it to be to split those two apart. Let's follow the ridge round here. So the ridge comes up here into the Indian Ocean, and then we can follow, there's a branch of it coming around here towards the Middle East. And we've got the Gulf of Aden there and the Red Sea, where you're just seeing the formation of the newest sea forming there, with some seafloor there as that begins to split apart. Let's come back down again into the Indian Ocean, back to that join, and this time we're heading east. We're heading east to the ridge between Antarctica and Australia. Again, another ridge exactly where we would be if those two continents split apart. And the ridge comes all the way down here into the Pacific, the widest ridge in the planet, the East Pacific Rise, which comes all the way here. If we pivot around there, there's South America, but we're heading towards Central America and up towards Mexico. And this peninsula here in the Gulf in between is the Gulf of California, and we can see the ridge coming up in here as well. Now, what's been happening here as the Americas have moved further west into the Pacific, that this ridge has been gobbled up and subducted, but we see just about the remnant here, and the ridges are bisected by transform faults, and we come all the way through California back to a transform fault here and another bit of a ridge, and joining those two, not shown in this map, is the most famous conservative plate boundary in the world. Yes, it's the San Andreas Fault. And we come back up here to this ridge, and then we start our journey on the Pacific Ring of Fire. So we are currently at Alaska here. This chain of islands is called the Aleutian Islands, and we've got our now glorious deep ocean trench with that arc shape, arcuate pattern. So it's the island arc. Those are all volcanic islands formed as the Pacific plate subducts down underneath the North American plate. And then we come around here, the Kamchatka Peninsula in Russia, round here towards Japan. We have this massive big subduction zone. When I zoom in here, you can see your volcanic islands that are around there. They're left by this whole process. And we come all the way down here to the Mariana Trench, to the deepest place in our planet, Challenger Deep. And again, you can see that arc shape. We come around here, across this place here, joined together by a few transform faults, to the Tonga Trench and the Kermadec Trench, another very, very deep ocean trench with your volcanic islands just there, down again to New Zealand. Let's take one final detour across here. We're going to come all the way now around to the south of South America, and down here to the Falkland Islands. And we'll just take a quick detour to this, another little trench in an arc shape of volcanic islands, the South Sandwich Islands. But we're going to follow this all the way up the western coast now of South America. There is a trench there, but it's been mostly infilled by sediment that has been transported off the continents. So as you get into these latitudes here, you start to get the trench getting deeper and deeper and deeper as we come all the way along the coast, South America, with the Andes just there. And we come our way round here to this trench, and what we can see here between all these feet is as we come in here to Central America, there's the Panama Canal, round here to Central America and Guatemala and the Costa del Volcan de Fuego. And this is a map of the oceans of the planet. Allows us to explore all of that evidence of the seafloor topography that led to the development of the theory of plate tectonics on a scale like I've never seen before.